all, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to delve into the topic Warshall and Floyd's algorithm. Let's get started. So first we have to know about what is Floyd's algorithm. The Floyd's algorithm, named after its creators Robert Floyd and Stephen Warshall, is a fundamental algorithm in computer science and also in graph theory. It is used to find the shortest path between all pairs of nodes in a weighted graph. This algorithm is highly efficient and it can handle graphs with both positive and negative edges or the negative weights, making it a versatile tool, a wide range for network and connectivity problems. So let's see what is Floyd algorithm. So the Floyd algorithm is also known as Floyd's algorithm, Floyd-Warshall, Floyd, or you can say WFI algorithm. So first let's see what is the definition. So the Floyd's algorithm is an all-pair shortest path algorithm unlike Dijkstra and Bellman-Ford, which are single source shortest path algorithm. This algorithm works for both the directed and also for undirected graphs. But it does not work for the graph with negative cycles. Make sure that it should not form cycles, where the sum of edges in a cycle would be negative. It follows dynamic programming approach to check every possible path going via each and every possible node in order to calculate the shortest distance between every pair of nodes. So let's see what is the idea behind the Warshall-Floyd's algorithm. Suppose we have a graph G with I, j as vertices with v vertices from 1 to n. Now we have to evaluate a shortest path matrix, and the shortest path matrix represents the shortest path between the vertices I and j. Obviously, the shortest path between I to j will have some k number of immediate nodes. The idea behind Floyd's algorithm is to treat each and every vertex from 1 to n as an intermediate node one by one. The following figure would show about how the Warshall algorithm works. So let's see what is the algorithm first. So the algorithm works like this. First we have to initialize the solution matrix as the input graph matrix as a first step. Then we have to update the solution matrix by considering all vertices as an intermediate vertex. The idea here is to pick all the vertices one by one and update all the shortest path, which include the picked vertex as an immediate vertex in the shortest path. When we pick vertex number k as an immediate vertex, we also have considered vertices 0, 1, 2, etc. up to k minus 1 as intermediate vertices. So the next step would be for every pair I, j of the source and destination vertices respectively, there will be possible of two cases. K is not an intermediate vertex in shortest path from I to j. We keep the value of distance I, j as it is. K is also, the next point is K is also an intermediate vertex in the shortest path from I to j. We keep the value of distance as it is. So we can update the value, or we can say the updation or the moderation formula as distance of I, j is equal to distance of I, k plus distance of k, j if distance of ij is less than distance of ik plus distance of kj. So this is how the algorithm works. So let us consider the example. So here there are several paths between A and D. So path 1 A to B, B to D, that is equal to 7, the weighted is 7, and path 2 it is A to C, C to D, that is also is equal to 7, and path 3 it is A to B, B to C, C to D. So the weighted cost would be 6. So there are several things to be noted here. There can be more than one route between each node. The number of nodes in the route isn't important. Path 3 has 4 nodes but it is shorter. The path 3 has 4 nodes but it's shorter than path 1 or 2 which has 3 nodes. There can be more than one path of the minimal length. So how to calculate? So the simulation can be the distance table by D0, D1, D2 etc. up to D1, and the sequence table should be S0, S1, S2 etc. up to S1, and the iteration would be for k times. So this is how for iteration 1 you have to find the distance matrix, and this example what we see in the screen is an example for iteration 1. So let's see the iteration 1. In the iteration 1 we have to keep the first row and the first column. We have to freeze the first row and first column, and you have to assign the number of weights from path A to A or A to B or A to C, whatever. You have to calculate the weights of each and every path. First row unchanged and the first column also is unchanged. This would be the for iteration K. That is the value is equal to 2. Here we have to keep row 2 and second column as unchanged. This is for iteration key. Here as always it is for a third row and third column would be remaining unchanged. This would be for iteration 4. And finally the output of this algorithm would be specifically as shown in the figure.